You are given a sorted list of non-overlapping intervals. Now, someone hands you a new interval and says, fit it in. Merge whatever overlaps. Sounds simple? Most people overcomplicate this. But there's a clean one-pass approach. Let me show you. The setup. You have a list of intervals already sorted by start time and no two intervals overlap. Now you get a new interval. Your job. Insert it at the right position. If it overlaps with one or more existing intervals, merge them all into one. Return the final clean list. Let's walk through it. Intervals are 1 to 3 and 6 to 9. New interval is 2 to 5. First, 1 to 3, does it overlap with 2 to 5? Yes. The end of 1 to 3 is 3, which is greater than or equal to the start of 2 to 5. So we merge them, take min start, max end, we get 1 to 5. Next, 6 to 9, does it overlap with 1 to 5? Number 6 is greater than 5. So we just add 6 to 9 as is. Final answer, 1 to 5, 6 to 9. Here's the key insight. Every interval falls into one of three zones. Zone 1, intervals that come completely before the new interval. No overlap. Just add them. Zone 2, intervals that overlap with the new interval. Merge them all by expanding the new interval. Zone 3, intervals that come completely after the new interval. No overlap. Add the merged interval, then dump everything remaining. One single pass. No sorting needed. How do we check overlap? Simple. If an interval's end is less than the new interval's start, it's completely before. No overlap. If the new interval's end is less than an interval's start, it's completely after. No overlap. And once we know it's after, everything remaining is also after, because the list is sorted. Anything that doesn't fall in before or after must overlap. And to merge, just take the minimum of both starts and the maximum of both ends. Here's the approach in plain English. Walk through each interval. If it ends before the new interval starts, no overlap. Just add it to the result. If it starts after the new interval ends, we are done with merging. Add the new interval, copy everything remaining, and return. Otherwise, it overlaps. Expand the new interval by taking the min start and max end. After the loop, if we haven't returned yet, the new interval goes at the end. First, the merger helper. It takes two intervals and returns one merged interval. Start is the minimum of both starts. End is the maximum of both ends. Simple. This is what we call whenever two intervals overlap. Here's the main function. We loop through every interval. First check if the current interval's end is less than the new interval's start, it's before. Just push it. Second, check if the new interval's end is less than the current interval's start, we are past the overlap zone. Push the new interval, then copy all remaining intervals and return immediately. Otherwise, overlap. Merge the current interval into the new interval. After the loop, if we never returned early, push the new interval at the end. Done. Let's dry run with the second example. Intervals 1 to 2, 3 to 5, 6 to 7, 8 to 10, 12 to 16. New interval 4 to 8. Index 0, 1 to 2. End is 2, less than 4. No overlap. Add it. Index 1, 3 to 5. End is 5, not less than 4. Start is 3, not greater than 8. So it overlaps. Merge new interval becomes 3 to 8. Index 2, 6 to 7. Overlaps with 3 to 8. Merge still 3 to 8. Index 3, 8 to 10. Overlaps. Merge new interval becomes 3 to 10. Index 4, 12 to 16. Start 12 is greater than 10. Done. Push 3 to 10, copy 12 to 16. Result 1 to 2, 3 to 10, 12 to 16. Correct. Time complexity O of n. We go through each interval exactly once. No nested loops. No sorting. Space O of n for the result array. That's it. The early return optimization means we often don't even look at all intervals. We stop as soon as we are past the overlap zone. Remember this pattern. 3 zones before, overlap, after. Before, just push. Overlap, merge by expanding. After, push merged interval, dump the rest, and return early. This same approach works for merge intervals, LeetCode 56. The merging trick min of starts, max of ends appears everywhere in interval problems. Master this, and interval questions become easy. If this explanation clicked for you, hit that like button and subscribe. Drop a comment what interval problem should I cover next. See you in the next one.